Okay, so we're going to start this practice problem set, Ps4.4 Part 1, with a series of some payoff matrices and some questions. And the most of these questions are pretty much modeled on what the AP exams are going to look like. In fact, that's what that question actually is. The bottom of this page is a short AP FRQ question that I've changed the names of the companies in it. So we're going to go ahead and get started. The first problem up here says we've got a player named Mr. Sywell and a player named Mr. Glossinger. And this is modeled on the Krugman textbook question with the nightclub and the movies. And it first asks us what's the dominant strategy for Glossinger, and if Sywell goes to a nightclub, what should Glossinger do? And then what will the two people do? And what that's really saying is like, is there a Nash? And if so, what is it? And we'll kind of observe that here momentarily. So we're going to see if Mr. Sywell will play as Glossinger first. That's me. We'll assume that Sywell does go to the club. So Glossinger can go to the nightclub and get 2, or he can go to the movies and get 5. So he will prefer 5. And if Sywell goes to the movies, right, we're in this column, then Glossinger can get 4, or Glossinger can get 3. And remember, the left numbers go with the left player. So Glossinger would prefer 4 utils. So it's clear here that there isn't one, right? There is no dominant strategy for Glossinger, because Glossinger might go to the movies and he might go to the nightclub. It just depends on what Sywell does. Now we know that if Sywell goes to the nightclub, what should Glossinger do? Well, Glossinger should go to the movies. Okay. Now we don't know what the two people will do, so let's solve for what Sywell will do. If Glossinger chooses to go to the nightclub, Sywell can either get 4 or 6. And Sywell will prefer 6. So we're comparing the right numbers now, since we're choosing between club and movies with Sywell. Now, if Glossinger goes to the movies, then Sywell can get 8, or Sywell can get 1. And Sywell will prefer 8. So this is what we call a game of avoidance. A game of avoidance, where essentially they are avoiding each other. And so there are 2 Nash equilibria. They might be club movies or movies club. So there are 2 Nash equilibria, and they are in those 2 corners. Now let's take a look at the second problem. This one just has firm A and firm B, and they have to advertise or not. And in determining a dominant strategy for A, what will A earn if B advertises? So this one is just asking us to read the payoff matrix. What will A earn if B chooses to advertise? And so in order to do that, we have to kind of actually figure out what A is going to do if B advertises. So if B advertises, A can earn 85, or A can earn 80. Now, what's A going to do? A is going to advertise and earn 85. So we'd say 85. If firm B chooses not to advertise, what will firm A earn if they make the appropriate decision? So if B goes in this row, A can get 60 or 70. They would choose 70. So they would earn 70. So that's kind of a classic interdependence there. What is the dominant strategy for B? Okay, well, if A chose to advertise, then B should advertise and earn 100, or not advertise and earn 75. Well, clearly they should choose to advertise. If A chose to not advertise, right, then we're in this column, and now B can earn 90, or B can earn 60. So B is going to choose 90. So B clearly has a dominant strategy to advertise, because they will always advertise, because their payoffs are higher either way. And so we know also that this is the Nash, is for them to both advertise, because neither one will deviate from advertising so long as the other continues to do so. Now let's take a look at this bottom problem here. Does each shop have a dominant strategy to set high, low, or none? And if If they don't cooperate, what will be the profit? And then there's a subsidy. So let's take a look at that in a second. So let's just go ahead and solve this first and then answer these questions. If Pickleman's decides to price high, then Potbelly can get 110 or Potbelly can get 130. So Potbelly will choose 130. And if Pickleman's goes low, then Potbelly can get 80 or 70. Well, they're going to want that 80. Okay, so Potbelly does not have a dominant strategy. Now, if, on the other hand, if Potbelly always goes high, now we're in this column. We're going to switch here. Pickleman's can get 105 by going high or 120 by going low. They're going to go low. And if Potbelly goes low, Pickleman's can go high and get 40 or low and 75. They're going to go 75. So we'd say companion, oh, I know what happened. This store closed in our town, so we're going to replace that with Pickleman's. Pickleman's. Oof. Which is also a good sandwich shop. Pickleman's. So Pickleman's has a dominant strategy to go low. Then we'd say Potbelly does not have a dominant strategy. Okay. And if they don't cooperate, what will be the profit? Pickleman's will get, it looks like here, Pickleman's would get 120. Because we're going to be in the Nash, is what this is really saying. If they don't cooperate, where will they end up? They'll end up in the Nash. And so Pickleman's would get 120, and Potbelly would get 80. If the town government is concerned that food prices are too high, and it decides to give a subsidy of 20 to any shop that sets low, redraw the payoff matrix under the subsidy, and then answer the following. So this is one where we're gonna redraw. I'll put it kind of over here. And this would be Potbelly. And this is Pickleman's. Okay. High, low, high, low. And just as an aside, it would be in your interest when you redraw it to redraw it exactly as it's drawn up here. Like, don't switch Pickleman's and Potbelly in high and low. I don't think you would do that. Some kids get creative. Let's not get wild and crazy. So they get $20 extra. This is what this is saying. $20 extra if they go low. So that means that only the low ones are going to get added by 20. So the low, the 75, 70, each one of those is going to get 20 added to it. 95, 90. And then the high up here, these are not going to change because they don't get the subsidy. Okay. And then we have Pickleman's going high and getting 40, and Potbelly going low and getting 130. So that 40 will stay the same, but 130 will have 20 added to it. And then over here, this is Pickleman's going low, so they'd get the 20, and then this is Potbelly going high, they won't get it. So we have 140 and 80. And now we can just we can resolve this, and it's important that when we go to explain using values in the matrix, and that's in this matrix. And this says compare to the values in B1. So let's go ahead and solve this and then answer these. So Potbelly, if they go high, Pickleman's will go low, and if Potbelly goes low, Pickleman's will go low. And if Pickleman's goes low, then Potbelly will go low. And if Pickleman's goes high, Potbelly will go high, or go low, because 150 is bigger than 110. So this has rearranged some of the dominant strategies a little bit, in fact, and you can see that we've got a new Nash equilibrium in the low box. So would Potbelly choose to set a high or a low price? Explain using values. So we're going to say they would set low because, and then what we're going to say is 150 is bigger than 110, and because you have to justify where they're always doing it, 90 is bigger than 80. So that can be your explanation for why they would do it. But again, we are going to use the values. If we don't use the values, we don't get the correct answer. C2 says, would profits for companion, and again, this is Pickelman's, right? Pickelman's, increase, decrease, or stay the same? Explain with a comparison to the values up here. So what did Pickelman's used to earn? Pickelman's used to earn 120. Now Pickelman's is going to earn here 95. Right? It's a little counterintuitive, but because we're moving out of this box and over to this one, that's our new Nash. So they would decrease because, and then all you have to do, explain with your comparison, is say the 95 is less than 120, which is what they earned before. So this is what they earn now, and that's what they used to earn, 120. So this hopefully helps you understand some of the concepts related to solving payoff matrices. We're going to do a couple more of them in class, but this is about as difficult as they're going to get. And I hope that this helps. I'll see you next time. Bye.